There are many ways to create and control 3D sketches in Autodesk Inventor. The first one we'll explore is using work points and sketch geometry to control the position and movement of a 3D spline. We'll start out by creating a new component. Once the new component is created, we can start a 3D sketch and begin by selecting work points in the assembly. We'll use these points to establish a direction for our line tool. So that the spline can be created to be normal to the sketch. Then we'll start our 3D Spline tool. In this case, I'll use an interpolation spline, which will allow us to follow points more closely. I'll select the endpoint of a line. Then, using the right-click menu, make sure to switch on ortho mode to begin. This will allow me to go along a direction, then transform down X, back down Y, and then begin picking points directly in the model. I can also resume using the directions. By clicking on one of the square faces, I'll shut off ortho mode and begin the process of being able to sketch in free space along a plane. Connecting to the endpoint of the line, we can apply tangent or smooth constraints to fit the spline to the lines. In some cases, where there's extreme curvature changes, you may get the spline flipping directions. Once you have objects in place, you can select any of the points and activate the handle to change the curvature weight. You can also use the 3D transform tools on any of the points to move them in any particular direction or to move them through a plane. Selecting the handle will allow you to apply controls for direction as well. Moving on to another example, we have our adapter part where we have a 2D sketch placed onto a work plane away from the component. I'll start a 3D sketch and use the Project to Surface tool. What I would like to do is maintain the length of this bend as it is applied to this surface. So I'll use the Wrap to Surface option, selecting the face that I want to apply to, and then the curves. When I'm done, I'll click OK, and you'll see the curve applied to the face. Setting ortho mode and making sure I'm on the face, you'll see that the end node is faintly shown to be the same distance. Finishing the 3D sketch, I'll make sure that my sweep profile is below the 3D sketch and edit the sweep profile. I want to project the geometry from the end of the 3D sketch into the 2D sketch so that I can align my profile. Now I'm able to finish the sketch and use the sweep tool to follow the 3D curve, cutting a J slot into this adapter. Any change made to the original sketch can be used to update the 3D feature. There's another sketch in this model. I'll move the end of part below that sketch and start a 3D sketch. For this 3D sketch, I want to create it based on the profile that's in the middle of the model and the outside face. I'll use intersection curve to select the face and then the profile. When I click OK, it will generate a 3D sketch on that face. As you would expect, if the geometry of the sketch or the face changes, the 3D sketch will follow. This is a great way to define a path for something like a sweep profile that will cut or add geometry along that surface. Now we can begin another 3D sketch and use the Curve on Face tool. Picking a point on the face or on the edge, you can freely start picking locations to apply a spline onto the face directly. There is some level of control available as well for being able to apply dimensions to locate the points. And any of the points can be clicked and dragged to relocate that aren't completely constrained. You can also fix a point as well. You can also add a point using Insert Point along the spline to add more detail. This is a great way to create complex shapes very quickly without having to create a 2D sketch to project. On the remote control part, we want to find where the parting line is on this complex surface. To do this, we'll start a 3D sketch and use the Silhouette Curve tool. The faces of the model are highlighted, and then we need to establish a direction. We'll use the Z-axis of the part, click OK, and it will generate a 3D sketch of the parting line in relation to a Z-direction pull. For people using the mold design tools of Inventor Professional, this 3D sketch can help you define the parting line for your mold.